Hello there. So this is Praveen Sai, and today we are gonna talk about basically what blockchain is, how it works, and why do we need it. So let us jump right into our video. So let us begin with what blockchain is. Blockchain is basically a distributed immutable ledger. It is the data stored on blockchain cannot be changed. A lot of jargons, right? So let us break down each of them one by one. So basically, let us start by what a centralized system is. A centralized system is, you can say, like a bank server. So if any person wants to change the data of any bank, and if he gets to a server, he can change that data permanently. But the most important thing in our blockchain is that the data must be always be immutable. It must not change in any criteria. Thus, a centralized system is not a good fit. Thus, we choose a decentralized system. What does a decentralized system mean? Decentralized means the data, each data which is created in a blockchain is copied and distributed across each and every computer on that blockchain network, which means in order to change any single record on the blockchain, you have to change that specific data on at least 51% of the computers in the network. Only then that data is gonna be changed forever, which is a really tough process, if I have to tell you. Okay, and that is a really big factor in making that blockchain immutable. And along with that, a ledger. What a ledger is? Ledger is basically a copy which is used to store some data. So we understood that basically blockchain is a decentralized. In blockchain, the data is copied. Each data which is created is copied and distributed across all the computers on that blockchain, and is stored on each and every computer. Each and every computer has a copy of that specific block, and that means that anyone on the whole blockchain network can create a block, and anyone on that whole blockchain network can verify it. There is no central authority to create a check the integrity of that data. But then what prevents me from saying that someone from Tesla sent me 100 bitcoins, and how can you check that whether it is original or not if I can only create that block myself, and I and some other friends of mine can verify it for me, because I didn't change the content of the blockchain after creating it. I just initially created a blockchain with wrong data. Then how do you check it or verify it if it is true, the transaction is true or not? We will check this in our next video, so stay. Okay, so the most important factor of blockchain is to keep the data immutable. But where does this immutability of blockchain actually help? Blockchain immutability is really helpful in various sectors. The number one is in banking sector, because like you don't want someone to be able to manipulate their own data of transaction and change the amount of money they already have in their bank account, because that would be really disastrous if anyone will be able to change their own data. And second is actually the voting system, because many of the time there arises the question over the authenticity of the data, which the voters data. But if the data is immutable in case of blockchain, then there cannot be any question over the authenticity of the EVM data, as it just cannot be changed. And the third one is the medical sector, because medical sector doesn't want the patient history to be changed unless someone creates something new, and the data must be stored indefinitely for later use. So yeah, these sectors can really be benefited from blockchain. Just like we store our data in computers in file, similarly the data on blockchain is stored in form of small blocks of data, and each data is connected to form a chain known as the famous blockchain. So the data does not really only needs to be of transaction. It can store any sort of data, is ranging from numbers to alphabets to digits, so to any sort of data. But the most famous blockchain, which is the Bitcoin blockchain, stores the transaction history. That's great, but now let us see what does the each individual block consist of. So as we know, each individual block in a basic manner consists of data, the hash of the data, the hash of the previous block, and the nonce. Now the data is the data which we want to store in our blockchain, which must not change, and the hash of the data is just like a fingerprint of that specific data. It changes as soon as the data changes, and we can get back the same hash if we put in the same data, but we cannot get back the data from the hash. Okay, so the hash is specific for each individual data, and the hash like the SH256 hash is always of a specific length, like 256 bits long, no matter whatever the size of the input is. And now the fourth one is the previous hash. The blockchain also stores the each block also stores the hash of its previous block in order to be connected to the previous one, thus forming a chain, which is the famous blockchain. And the last one is the nonce. So basically a nonce is just a random digit which is used for the mining of blocks. Mining of blocks means the creation of blocks, and this will be discussed later on. Much of the theory, let's start the practical right now. So a huge shout out to Mr. Andrew Brownworth for creating this visual demo for blockchain. It's really great. He has also some really great videos on blockchain on YouTube. You can also check him out. The link is in the description. So let us start the journey. So yeah, first of all, let us begin with the hash, the relation between data and hash. So yeah, as we know, our hash is just a fingerprint for our data. Like it changes as soon as you change the data, a capital A, and we can get back the same exact hash if we again enter the same data, but there is no way to get back this same data if we enter back the same hash. Okay, now that's great. And another property of the hash is this, that no matter whatever the length of the data is, the length of the hash will always be of a specific length. Like this is an SHA-256 hash, so the length of the hash will always be 256 bits. It is 64 characters only, no matter whatever the size of data is. No matter if you keep it empty or just fill it with something random, it will always be only 256 bits long, and you cannot get back the data from the hash. So yeah, that's basically data and hash. Now let us move to block, a basic structure of block. This is a basic structure of block. Here you can enter some data which you want for your block, and now for the creation of block we have to mine it. What does mining mean? Mining means we collect all the data we want in a block, and then we have to do some proof of work, which means that we have spent some computational power in order to create this block. Here proof of work is used to find nonce. Like in most of the blockchains, the hash must start with certain specific number of blocks, certain specific number of zeros. Like here the hash must always start with, let me see, a hash must always start with 4 zeros. Okay, but since we know our data is unique, so our hash is also unique for that specific data, so we cannot change data, we cannot change the hash for this specific data. Then how do we make our hash to start with 4 zeros? This is where the nonce comes. Nonce is just any random digit from 1 to any digit which makes this which combination of nonce and data makes the hash start with some specific number of zeros. Like this is hey, okay, and we want such a nonce such a combination of nonce and data that our hash starts with 0. So let us mine it. So yeah, our block will be mined. This is a sample only. This is why it is not gonna take that much time. But on a real blockchain like Bitcoin blockchain, it goes to trillions and a huge number. Like uh this is currently 1,12,744. We Our computer had to loop through all numbers till 1,12,000 in order to find this specific nonce and check for each nonce whether it provides the required hash or not, required like hash starting with 4 zeros or not. So that's basically mining for us. Now let us move to basic structure of blockchain. So yeah, this is a basic structure of blockchain. Our block contains our block number, our nonce, our data, and our previous hash and the current hash. Okay, this previous hash is the hash of this one. Okay, so now let us imagine we are some bad guys. Okay, and we want to change this data. It is currently empty. We want to change its data. Now, if we change its data, then we have to remine this block again. So this in itself is a really uh, computational heavy work in itself for to mine one block. But since when we are gonna mine, the hash of this data will also change because we change the basic data. So the hash of this data will change, making the previous hash on the block number 5 invalid. So basically, if we mine any block, if we change any data on a block, then we also have to remine all the following blocks after that. So if you change any data on the last block, like block number 5, then you only have to remine this specific block, which is still a huge computational task. But if you go on and modify some previous block, then it is gonna be a really huge computational problem for you, which will take just a huge amount of time. Making one block on a Bitcoin blockchain requires a huge amount of energy along with 5 minutes of time. So yeah, this is just a sample. On a real blockchain, it contains thousands and thousands and thousands of blocks. So yeah, you have to, if you have to remind all of them again or even a fraction of them again, then but this is the uses of hash in making our data immutable. But let us see how the distributed network of a blockchain also makes it pretty immutable. Okay, as we saw that if we change this previous block, then we have to also remind all the blocks following that. But what if we just change the last block? Like let us say we change it to hey, and now we remine it. So yeah, now we had reminded. So yeah, we did it. But if we remine it and we only have to remine one block, then it's not that big of a difficult. So are you telling me that the last block is not immutable of any sort? No. This is where our distributed network of blockchain comes really handy. Like when a block is mined, all the other people on the network verify the reliability and authenticity of the block by checking first its hash, that, and if the hash consists the required number of zeros, it is the phone number of zero, then it checks whether the authenticity of that blockchain, whether that blockchain is believable or not. Like this whole blockchain, the only thing it has to do is just check the last block on this specific blockchain, like this one. Okay, so it check its hash is ends with 404. Now on all the other computers, the last block, it is the block number 5's hash ends with 17c, and also on PSC the hash ends with 17c, which tells us that this block or any previous block on this blockchain has been tampered with, making this specific blockchain not trustworthy, and thus it is not a good blockchain. And this blockchain of peer A is invalid, and no blocks on this blockchain are then gonna be added to all the other networks. This blockchain is invalid. So yeah, that's pretty great. So now if you have to change, if you have to bypass this distributed system, then you must have control over 51% of all the computers on the network, on the blockchain network, and then you have to remine this specific block on each of those computer, which in itself is really computational heavy process. And let alone that, the owning of 51% of the whole blockchain is a really big deal, because it is a really huge computational power, and there are a lot of computers, by the way. So that's it. The distributed system of blockchain, along with the great uses of hash, is what makes this blockchain pretty much immutable. So yeah, that's great.